Good morning. This is Unit 3, Day 4 notes. It says that you are tracking the position of an ice cream truck in your neighborhood relative to your house located at 0, 0, the origin. At noon, the ice cream truck is at A, which is 220, which I found. I went over to the right 2, and then up 20 is right here. So this is our vector. And is traveling in the direction of 4, -3. Remember, this is kind of the opposite of slope. The 4 are my x values, so I'm going to go to the right 4. 1, 2, 3, 4. And then I'm going to go down 3. 1, 2, 3. And my new vector is going to be this. Okay. 4, 3, 4, -3. It has a constant speed of 5 kilometers per hour. At 1 p.m., the truck is at the point 6, 17. Well, this point right here is 3, 4, 5, 6, and then up 17. This is our point, 6, 17. The vector 4, -3 represents the velocity of our ice cream truck. Note that the vector 220 is the initial position where we started. So this is going to be the initial position or position vector. I want to put an. We can represent the ice cream truck's path in 3 different types of equations. The first one is a parametric equation. We're going to use this often when we have 3 variables. A parametric equation defined by the position at any time t. We usually have a one extra variable, and this is going to be our input. And then our x, y, maybe even z is going to be our output. So time t in hours is called the parameter. This is called the parameter. So at 0, or time 0, my initial time, or at noon, I know that my x at noon is at 2 and my y value is at 20. And then it says at 1 o'clock, my x is at 6 and my y value is at 17. Assuming that there's no change, let's keep going. When I go to 2, what did I do to get from 2 to 6? It looks like I can just add 4. So 6 plus 4 is 10. And from 20 to 17, it looks like I am subtracting 3. So I'm going to do it again. 17 minus 3 is 14. What we really need is an equation. So this is just going to be our t. But how does this relate to x? Well, let's see. If I keep on adding 4, it looks like it's just going to be 4t. But I have to add what I started with. I didn't start at 0. We're going to start at 2. And my y in relation to t, it looks like I'm just subtracting 3 each time. So I know it's going to be -3t. But this one, I'm starting at a positive number. So I want to put this first. My positive number is 20. So I have 20. And then I would just put minus 3t or plus -3t. That's fine, either way. So I have a parametric equation that is x equals 4t plus 2. And y equals, you can put this first if you want, negative 3t plus 20. Doesn't matter. As long as the 20 stays positive and the 3t stays negative. As long as t is a real number. Okay? This is our parametric equation. This is how easy it is. Also, we have a Cartesian equation. You guys are used to this one. We're just going to solve for t. Alrighty, so we know that x is equal to 4t plus 2. If we solve for t, we're going to subtract the 2, divide by 4. T is going to be equal to x minus 2, all divided by 4. And now we can plug that into the y. So I know also that y is equal to, I think it was negative 3t plus 20. But I know what t equals. This is t, and we're going to plug it in for this t. So I have y equals negative 3 parentheses, use your parentheses, x minus 2 over 4 parentheses plus 20. You can simplify this, distribute that negative 3, or we can multiply everything by 4 to kind of get rid of that denominator. Everything by 4 though, even the y. So I have 4y equals, distribute this negative 3, negative 3x plus 6, right? And then 4 times 20 is 80. Yeah. And we can just combine these. And I will simplify that and get, I'm going to move this 3x to the other side. So I'm going to add it to move it to the other side. This is our Cartesian equation, is 3x plus 4y equals 80 plus 6. So this is in terms of x's and y's. Now our vector equation, let's look at what this vector equation is going to look like. This one's a little bit new. So my vector equation is going to be, well, let's first make these into vectors. I'm going to make this black vector A. And I'm going to make another vector to show the second position, which is going to be pink. And we're going to make this one R. Okay, R. And then our green one is B. Now I can easily make a vector equation. It's going to be vector OR. So this second vector is OA plus A to R. Remember, this is A and this is R. Okay, so O to R is equal to O to A plus A to R. O to R is any position on the line. Any. And then O to A is my initial position. They told us that, that A is our initial position. And then eta r is our displacement or our slope or our direction. We're going to call this the displacement. Displacement from initial position. Alrighty, so this is going to be R equals A plus, and then T, our time, times B. Also, we'll use lambda for time. Okay, so in this case, we only have 2 dimensions, so I'm going to make this xy. Our initial position, they told us, was 220. That was our initial position, 220. Plus time times our slope, or our displacement, which they told us is 4, -3. That was it. That's it. All right, it says find the parametric Cartesian and vector equation of the line parallel to 3, -1. This is our direction. And through, this is our initial point. So our vector equation is pretty easy. We'll use this one first. Remember, it's R equals A plus T times B. R is xy. We only have 2 variables in this one, 2 dimensions, so xy equals our initial, oh, I did purple, our initial vector, which is 7, -5. Plus, and then the direction is going to be T times 3, -1. Ta-da! Pretty easy. Let's do the parametric. The parametric equation. Alrighty, so we know that x is equal to our initial point, which is our x value, 7, plus our slope, which is, or our direction, which is 3 times the time. Also, let's do y. My initial, which is -5, plus -t. So let me just say minus t. -1t, or minus t. Now let's do our Cartesian. Oops. We have to solve for y and for x. I think it'd be easier to solve, or we have to solve for t in both. I think it would be easier to solve for t and the y and then plug it into the t and the x. So we have y, and then we're going to add the 5 to move it over and divide by -1. So y plus 5 all over -1 is equal to t. So t is equal to -y minus 5, just the negative of the top. Okay, now I can plug that into the x value. X equals 7 plus 3 parentheses and then -y minus 5. I'm going to distribute this 3 to both, and I'm going to move this -3y over. You guys can do this in a couple steps. X plus 3y equals, check and make sure I'm right. Now let's look at what happens when we add this third dimension. So lines in three-dimensional space can also be represented by three types of equations. To 2D, suppose M, X, Y, Z is a point which is free to move on a line, contain a fixed point F, let B be the directional vector of the line. So my vector equation is going to be the same. We're just going to add another variable. This is still the initial. We say X naught, Y naught, and Z naught for initial, or when we have that sub-zero. And then this is lambda, same thing as our time directional vector. Okay, so suppose M, a fixed point F, and let B be the directional vector line, then O to M equals O to F, our fixed point, plus T times the directional vector. So this is our equation also. Remember, this is the point on the line. This is our initial point. And this is the directional vector still. Okay, the parametric equation is going to be similar to the last one. We're going to have the initial point plus, and then lambda A, initial point plus lambda B, and then an initial point Z naught plus lambda, and then C for this direction ABC. The Cartesian coordinates, or the Cartesian equation, we're going to solve for lambda, or T, and it's going to be X minus X naught. We have to move this over. So we have to subtract it, and then we're just going to divide by A. We're going to do the same thing for the other ones. Y minus Y naught divided by B, and Z minus Z naught divided by C. Lambda equals. Alrighty. Let's do an example. Find the vector equation of the line parallel to 2, 1, 3, and going through this point. So this is X, Y, Z. There's 3 dimensions this time. Equals my initial position, which is 1, 3, negative 7. Plus T times my directional, which is the 2, 1, 3. Parallel. This is my direction. Two, 1, 3. There it is. All right, let's look at this one. It says through 0, 1, 2, and with a directional vector of I plus j minus 2k. Okay, so we know that my directional vector is this. If I want to make this a vector in the same form, remember it's going to be in alphabetical. So I is 1, j is 1, and then k is negative 2. The coefficients in front of them. It's pretty easy. Now I'm just going to do the same thing. We have x and y and z equals my initial point, which is 1, 3. Oops. I was looking at the top one. So this one is 0, 1, 2. And plus lambda, or time, times the 1, 1, negative 2. There it is. Alrighty. Ooh, perpendicular to the YOZ. This is parallel to the other axis. So they have y and z. Well, that's parallel to the x-axis then. This is how I remember that. Now, if it's parallel to the x-axis, then our directional vector is going to be parallel to the x. So there's 1 for the x, and then 0 and 0 for the y and z. This is going to be my directional vector. Okay, now let's just make it into a line. We have x, or a vector x, y, z is equal to our point, which is right here, -2, and then 2, and then 1, plus t times the 1, 0, 0. So whenever we have something like perpendicular to the YOZ plane, then we're going to, it's going to be parallel to the other axis that we don't have. And then that one is going to have the 1. The other ones are going to be zeros. Find the parametric and Cartesian coordinates through this line A and B. Find the directional vector. Okay, so step 1, we can find AB or BA. I'm going to do AB. Find the directional vector. It doesn't tell us, so I'm going to do AB or BA. So I'm going to do AB. Remember, AB is B minus A. Just remember that. So we need to find B minus A. So I'm going to start with -1, 3, 2, and I'm going to subtract 1, 2, 1. This gives me -2, 1, and 1. Make sure. This is AB. Okay. It says step 2. This is my directional vector. Step 2, identify a point you can choose. We can use A or B. It doesn't matter. Let's do A or B. Oops. It says a vector equation. Okay, we have x, y, z equals my initial point, which we can use A or B. It's up to you. I'm going to use A. Plus the direction. So I'm going to use t. You can use lambda also. And we found our direction. It's -2, 1, 1. The parametric equation, we need to remember how to find the parametric. I know that x equals, and I just kind of follow along the top, x equals the x value plus -2 times t. So 1 plus -2t, right? My y's are the middle line. Y equals 2 plus t. And then finally z equals 1, my initial 1 plus t. There you go. My Cartesian equation is going to be x minus x naught. So x minus x naught over a, which is -2. And we have y minus y naught over 1, because that a is 1. And z minus z naught over 1. Okay, let's go over number 3. It says find the coordinates of the point where the line with the parametric equation meets the xy plane. On the xy plane, z equals 0. There is no z. Okay, so I know that z equals 3 minus 2t, but z itself is 0. Well, now I just have one variable and I can solve for this. So I'm going to subtract the 3, divide by -2, t equals negative divided by negative, so it's just 3/2. Okay. Now I can find the other ones. Plug in t, or substitute in for t. X equals 1 minus 3/2. So x is 1/2. Okay. -1/2, -1/2. So I'm going to have -1/2 first. And then y equals 3 plus 3/2. So you can say that this is 6/2. So y value is 9/2. And then we know that z is 0. Okay, it says meet the XOZ plane. In the XZ plane, our y value is equal to 0. So you're going to do the same thing with y. Let's look at number 4. It says the line L is parallel to the vector 3, 2. Okay, this is our direction. Find the gradient. The gradient, or the slope, remember, is y over the y's over the x's. So my y value is 2 over the x's, which is 3. The line L passes through these points. Find the equation of the line in the form a x plus b. Okay, so I'm going to use this point, and I'm going to use my slope. So I know that my y value, this is x's and y's, is 4 equals, my slope is the 2/3. And then my x value is 9. And we don't know b. We got to figure that out. 2/3 times 9 is 6. If I subtract 6, we get b equals -2. Okay, now I can just write the equation of a line. Y equals my slope, which is 2/3 x minus 2. Write down the vector equation of the line. Okay, so this is still in 2 dimensions, x, y. I need my initial point, or a point, which is, in this case, 9, 4. Sorry guys, the bell rang. 9. Oops. It's a horrible 9. 9, 4. Plus either lambda or t. I'm going to use lambda. And then our direction, which is the 2/3. But remember, x's come first. So this is 3, 2. All right, guys. I think that's going to be it for today. Let me know if you guys have any questions, and I will see you in class. Have a wonderful day.